look at it worldwide, and this is some stat counter. This is under 3 million sites. So this is probably one of the broader ones across the globe. What they're finding is that the share of Internet Explorer is going down, 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 down. Firefox went up. Right now, recently been a little flat. Chrome is growing up. And so when you add these two, it's clearly growing and very, very rapidly with these trends. It's going to dominate. But that's worldwide. If you go to Europe, for example, and this is where it shows you the strong influence of different countries around the world. Europe has been very strongly pressing to ensure that there is a level playing field, that browsers can compete without users essentially being forced to particularly default. And because of that, Firefox already leads. When you add Chrome, the majority of web browser use in Europe is open source. I don't have the stats to display. There's a contrary there in South Korea. The South Korean government is doing the policy in impossible to use anything other than Internet Explorer for any banking or financial transactions. And as a result, there's mostly Internet Explorer, which is the world's worst security record of all the browsers. They're requiring it by financial services. Not a smart move. They've recently changed it, but there's some unfortunate legacy. There are other people who keep track of web browser and track a lot of searches. Net applications is one. They found 40,000 websites, daily users per country, and they come up with similar data. Really one of the reasons I want to show this is that every time you try to gather data, there's always challenges. They weight by country based on CIA data, on the number of users in the country. You know, CIA data reported different values during the recalculating things. That's so rich. This is one of the challenges in this gather data is finding useful information that makes sense. All right, market share. Again, I'm going to wrap up on the market before we take the next slide. Smartphones. And we're saying, where's Linux on the desktop? Well, Linux on the server has been there for quite some time. I use Linux on my desktop. Works great. However, what's really happening is that the smartphones have showed up. And these are 3 different sources of the ComScore, Gartner, Nielsen, and depending on how you measure things, either the Android, which is Linux based, is already past the iPhone or is about to. But frankly, no matter how you guys do, it's still a question of exactly when that happens, not if that will happen. And the trend lines are really quite remarkable when you think about it. Something you probably can't see. From 2009, it has practically nothing. By December 2010, it's already right there. It's already on par with the leader. So that's a remarkable growth. Remarkable growth. Lots of other market share examples. Of the top 500 supercomputers, 93% are FLOSS. All but one of them actually are based on Linux. There's one based on Open Solaris. DNS, every time you type into a web browser, google.com, it's got to translate that into numbers. So although it can be difficult to do some statistics on DNS, oftentimes people have to look up the other direction, and they found that it was not that hard to do statistics on that. An open source software program called Bind does 95% of those. I'm going to jump down here to OpenSSH. OpenSSH is an implementation of a protocol, of a secure protocol called SSH. And the key point to know about this one is how quickly FLOSS can take over from existing organizations. Back in 2000, it had about 5% of the market. And very, very rapidly, by 2004, it essentially owned the market in terms of SSH deployments. All right. Now, that was market share. There's lots of other statistics, by the way, on all these things. But what I'm trying to do is provide you enough information that, hey, this stuff is not weird or unusual or useless. It's already used. It can at least be reliable and so on. I'd like to point out and discuss a little bit the FUZZ studies. What's interesting about the FUZZ studies from University of Wisconsin is that they weren't trying to find out about open source software at all. They were just trying to measure reliability of software. And they didn't really at first think that there would be anything special about open source software. And their first studies found that Well, I should quickly describe what the FOSS studies do. What the FOSS studies do is they just send vast amounts of random data to a program and see if it crashes. They're not worried if it works, produces correct results. The only thing is, can the program just keep running? Now, if you were from Mars, you would assume that, well, every program should be able to handle that. What a trivial test. No program would fail that. Of course, those of us who actually have to deal with software on a daily basis, particularly certain really badly written software, know that, in fact, there's some really bad software that can't even handle this relatively simple test. What they found was that 28% of the Unix utilities were failing this relatively simple test. What's nice about the FOSS study is that this is a test you can apply to pretty much any application. Well, they told the Unix vendors all about this. These are proprietary. And they came back, I think 5 years later, and it was down to 23%. They hadn't even fixed many of the defects that they've been told about, which is truly sad. So a little improvement, not much. But then they tested the open source software components, and they found a remarkable result. The open source software products were markedly better, 6% and 9%, depending on for 9% was for entire distribution, and 6% was for the GNU utilities. Remarkably better. I mean, we're talking, more than 2 to 4 times better than these guys. And what's even more interesting is that somebody else who is not part of any of those open source software projects actually set up a special project just to eliminate every bug found that these guys found. And so after their studies were done and so on, they actually ensured that every single one of the problems that had been found were fixed. Now, I'm hoping that some of you can read the Windows story. Those of you who are laughing or can read the chart. Okay, 100% failure. Yes, sir. I don't remember which, but it really wasn't. These are really the Windows applications and utilities. But the problem, I don't remember which version of Windows that they had. But let me point out something to explain what's going on here. It turns out that the Windows application programmer interface has some really fatal flaws in it that makes it impossible, well, practically impossible for a program to actually withstand this test at all. It's not possible to make a highly reliable program with this interface. Great. So what they did is they changed the nature of the test. So unlike all these other data, this is a simpler test where they intentionally eliminated some of the data, and they're still crashing all over the place because it's very, very difficult with that interface. It's not to make highly reliable software. Lots of other data. Yeah, you're talking about the next, I'm sorry, you're talking about this next one. This was an old one, but actually this points out a problem with some of the reliability numbers. They did a study for 10 months, basically set up Linux systems, at least one Windows, I think it was multiple NT systems, I don't remember how many Windows systems, but they set up systems, and then they had simulated activity going on night and day, 24/7 for 10 months. I will be fair, I won't be fair. NT actually didn't do that bad. It only crashed every 6 weeks. The thing is, after 10 months, the Linux systems never crashed. Now, this should also show you why it's difficult to do reliability tests. It's hard to take this length of time. But on the other hand, that's pretty darn impressive. NT not doing too bad, but frankly, that's far more impressive. Let's see here. And some other data, which I don't have time to go through. There's been a lot of automated defect detection analyses of various programs. The Linux kernel, MySQL, actually the last one there is a Linux kernel one as well. Coverity actually more recently did a study of the entire stack used in Android. And basically what they're finding is that it's not that open source software is automatically perfect. In fact, that's not what they're finding. But what they're finding is the defect rate is far lower. And ideally, of course, your defect rate would be 0 defects, no matter how large. But let's be realistic. That's a very, very difficult goal to achieve. And much lower defects than your competing alternatives is still pretty darn good.
What do you mean about rating?
Let's see here. In this case, let's see here. This is the different studies have different measures here. This is defects per 1,000 source lines of code. And MySQL had 0.09 defects per case log, whereas the industry average for the kind of measure that they were using was 0.57. So, your 0.09, you'd like it to be 0, but 0.09 is still better than 0.57 by far. It's not even a small difference. Scalability. First of all, I don't even have to measure some stuff to tell you that in any operating system that can scale between PC hardware, mobile phones, mainframes, clusters, supercomputers, cloud, and so on, that's pretty darn impressive. And again, of course, most of these supercomputers are using an open source software operating system. Now, there's another kind of scalability that I think is important too. And that's scalability of building large systems to solve large, complicated problems. The received wisdom really up till the mid-90s by many, not by all, but by many, was that, well, open source software can work for small programs, but you can't build big programs that way. And so when I first got my hold on a Linux distribution and said, wow, that's amazing. How much source code's in here? How big is this? I did a study, 2001, and found that a particular distribution, Red Hat Linux 7, had 30 million lines of code, which represented about 8,000 person years of effort and about $1 billion of effort. That's a B.